All right, so in 8.1, we divided it into two parts. The first part was Pythagorean theorem, which was that it is a right triangle. If it is a right triangle, then a squared plus b squared equals c squared. Then we did the converse, which is the second part, which is what this is going to cover. So the converse said that if c squared equals a squared plus b squared, then this classifies as a right triangle. If c squared is less than a squared plus b squared, then this classifies as an acute triangle. And if c squared is greater than a squared plus b squared, then the triangle is obtuse. We have to make c the largest of the sides. So the other two don't matter, but the c has to be the largest when we compare these. So if I look at number 3, 6, 11, and 14, what number is going to go on the side by itself? 14. The 14. So I would say 14 squared has what relationship to 6 squared plus 11 squared? 14 times 14 is?
196.
Should be.
It is.
96, right? Yep. 196. 6 squared is 36. 11 squared is 121. Add those together, and I get 196 is what relationship to 157? This would be greater than, making this triangle obtuse. Okay, then I have 15, 20, and 25. What's going to go by itself? 25. So 25 squared has what relationship to 15 squared plus 20 squared? What's 25 squared? 625. What's 15 squared?
15? Sorry.
Yeah, it's okay. 225. 20 squared? 400. Good. So 625 has what relationship to 625? They're equal, which makes this triangle a right triangle.
I have a question.
Mm-hmm.
I did 20 squared plus 15.
It's okay. That order doesn't matter as long as the biggest is by itself. All right, and then last one, 11, square root 11, square root 7, and 4, right? These are the ones that aren't as easy to figure out what's the biggest. We can approximate them. I know 11 is in between root 9 and root 16, and it's bigger than root 9, so let's say this is like a 3.2-ish. 7 is in between 4 and 9, so this could be like a 2.5-ish. And then 4 obviously would be the biggest of those. That's one way to look at it, right? So I would say that 4 is biggest. So the other two are going to go on the other side. The other way to look at them is square them. So the square of 11 of square root 11 is 11. The square of the square root of 7 is 7, and the square of 14 is 16. Then rearrange them so the biggest is by itself. But now they're already squared, so we won't square them again. So that would end up looking like this. And then I'd get 16 has what relationship to 18? It's what? Less than, which makes it acute. Questions on those? Yep.
I did it wrong, but it's still not cute.
Just be careful. You might be got lucky. How do you mean you did it wrong?
I did 7 square root first.
Okay. So be careful. Just because it's acute, that worked. If it was obtuse, it would have been wrong. So the three theorems in 7.5 went kind of like in this. The first one was the parallel lines. So if we say parallel lines cut off proportional segments, right? So if I look at this first one, I can set up a proportion. What can I put over what? Miguel?
5 over 3.
I could put 5 over 3 would equal what?
X over 6.
X over 6. Good. What else can I do?
5 over
I could do 5 over X
3 over 6.
equals 3 over 6. Okay? Or I could reverse them, right? I could go right, left, bottom, top, all that good stuff. So it doesn't matter which of those you solve, except there's a little bit of an easier thing with the bottom one, because why? What can I do with 3 over 6?
You can simplify.
I can simplify that, and I can make it 1/2. You do not have to do that, though. You can stick with the top one. It would be fine.
So you use the answer.
Same answer. You just have to divide at the end. Right now, all I have to do is cross multiply, and I get 1x equals 10, so x equals 10. With that top, I'd get 30 equals 3x, and x would equal 10. So it doesn't matter which way you do it, you end up with the same answer. All right, you set up the next one. All right, give me one way to set it up.
I got 5 over X.
Caesar, go.
Okay, 5 over X,
Is that the same thing?
and then 2 over 6.
Okay, did you reduce that?
Yeah,
So you made it 1/3?
yeah, and then I got X equals 15.
Okay, anybody set it up a different way?
5 over X equals 2.
5 over, no, that's the same, it would be safer. 5 over, you could do 5 over 2 equals x over 6, okay? You get 2x equals 30, x still equals 15. Both are right. Questions on that one? Okay, so what happens, listen. What happens if instead of this 6, you saw something like this?
That the whole line is equals 8.
The whole line is 8, which would do what? How do you get to that next part? How would I know what this is?
You subtract.
Subtract the 2 from the 8, and I would get that that's 6. Does that make sense?
Yes, ma'am.
So it's the same information delivered in different ways, okay? If they give you the whole in the part, make sure you take away the part to make the other part, okay?
Take out the 6.
If the 6 was not there, was what I was saying. If it was
So then you would subtract 8 by 2.
correct.
Hold on, don't move yet.
All right, the next theorem was the triangle with a parallel line in it. It does the same thing though. It breaks these sides into proportional segments. So what's one way I could set this up? I could go top, bottom, right? I could do 8 over 7 equals 16 over x. Or I could go left, right, and I could do 8 over 16 equals 7 over x. As long as you follow the same pattern, either of those works. The benefit to the second one is, again, that can be reduced. 8 over 16 can become 1/2, and then we multiply. I get x equals 14. If you kept it the first way, I get 8x equals 7 times 16. X equals 112. And then I'd have to divide 112 by 8. That's once. 4 times. So I get the same answer. It's just the second way is a lot easier because I'm able to reduce it. Caesar. You can do 7 over 8 equals x over 16. Sure. I just can't put 7 over 16 or x with 8. You just can't make the x. You could go left, right, top, bottom, top, right, left. You can't go across. All right, you set up the next one.
Can I do this one?
Yes.
Yes. 6 over 9
Okay.
equals 2 over X.
Okay, did you reduce?
Yes, I should do it. 2 over 3 on the 6 and the 9.
Good.
Then I multiplied, so it's 2. It's 2x equals 6.
Good.
And I just divided it, gave me x equals 3.
Good. Anybody set it up different? Anybody go 6 to 2? Yeah.
I went 9 over x over 6 over 2, and then I simplified the 6 and a 2 to 3 over 1, and I times the 3, and by x it became 3x, and the 1 times
Good.
9.
Good.
I don't know you can simplify it.
Yeah?
It's not the same like numbers. Like the 2 over how you did 2 over 3. Can't you just simplify it like
You're simplifying just this individual fraction. So both of those are divisible by, oh, yeah, both those are divisible by 3. Does that make sense?
it said 2, so I was like,
No, you're dividing them both by 3. Yep. All right. Then comes the triangle with the, hush, focus. Angle bisectors, right? This again only works with the angle bisectors, so you've got this little angle marked in here, but it still cuts them into one. The two sides would be proportional to the bottom. So I can say 16 over x equals 12 over 9. So I went the left sides and the right sides. Or I could go 16 over 12 equals x over 9, or the reverse of any of those. I could go right, left, and then bottom, top.
You can simplify.
Yep, so if I did the first one, I could simplify both, but if I did the first one, 3 goes into both of those, that'll be 4 over 3, and then I can cross multiply. 4x equals 3 times 16. That's 48. Divide both sides by 4.
The answer's 12.
Good.
Thank you, Musa.
This one you could have done by 4, so that would have been 4 and 3. 36 equals 3x, and x equals 12. Same answer either way. All right, you set up. Shh. Go ahead, Musa, set it up. All right, who's going to give me the proportion?
I'll give you the proportion.
Okay,
6 over 4.
6 over 4.
Equals 9 over 8.
Okay. Miguel, can you go from there?
Alright, hold on.
Wait.
Okay, got you.
What happened?
So, we're gonna do, 3 over 2.
Good.
Then we do 3x equals, 18.
Good.
And then we do, I didn't, 6.
Good. Anybody set it up different? Go.
I did 9 over 6 equals x over 4. And then I simplified 9 to 3 and 6 to 2. Cross multiplied 2 and x, you got 2x. And cross multiplied 3 and 4, I got 12. And then I got 6 as the answer.
Good job.
That's the right answer. Yeah.
About your quiz. You guys sometimes make mistakes in the work, right? If you try to do that stuff in your head and you make a mistake, I can give you no credit. But if you can at least give me a setup, let's say there's 10 questions, each of them are worth 10 points, and you give me a setup, I will give you partial credit. But you need to make sure you're showing your work, okay?
This is a quiz, basically.
It's a lot like the quiz. Yep. Minus the notes on it, but yeah. Questions? Okay, again, think about variations on this kind of question. What happens if I don't give you the 6 and I give you this whole thing is 15?
15 minus 9.
Good. I do 15 minus 9 to get the 6. Yes?
Really fun part.
Okay. Then came 8-1, which was Pythagorean theorem and the converse, right? So the top says use the theorems from 8-1 to answer the following questions. If a triangle is a right triangle, then what is true? What's the Pythagorean theorem? A squared plus b squared equals c squared. And c is the longest side. Or its opposite, the right angle. All right, so what is C in that first question on the left-hand side? What would I make C? The y. So I would do 5 squared plus 10 squared equals y squared. What's 5 squared? 25. What's 10? What's 10 squared? 100. What's 25 plus 100? 125. So then I go to square root it, and I get the square root of 125. Then I break this down, right? 5, 25, 5 and 5. There are 3 5s there. 5 times 5 times 5. Each pair brings 1 5 to the outside, and then the one left over would be underneath. So half of the challenge here is the simplifying of the square roots. Again, if you can get me to here, I can give you partial credit, but you got to make sure you're showing all your work. Yep.
Is it just make you put our same plus 5 or root 5 or do you put 5 square root 5 equals x?
You could just put 5 root 5. Yeah. Yep.
Why'd you put x instead of y?
Oh, I just wrote the wrong variable. It should be y. Okay, then B. Okay. Now what's by itself? What's the C? Square root 85. So I would do 6 squared plus y squared equals the square root of 85 squared. What's 6 squared?
36.
What's the square root of 85 squared? 85. Because when you square a square root, the square root goes away. Subtract the 36. You guys, I'm trying to review for your quiz over here. Please. Grow up just for a little bit. All right, then I got y squared equals 49, and y becomes? Good. Square root of 49, which is 7. All right, so what in A, what's the C?
It's 11 to,
What's the C, what goes by itself? The 61. And how do I know that?
over Ben.
It's opposite the right angle, right? This time I don't know if it's the longest because they're kind of close, right? But opposite the right angle is always going to be the longest. So I'd get y squared plus 11 squared, or 11 squared plus y squared, that doesn't matter, equals 61 squared. Y squared would equal, or y squared plus 121 equals 61 squared, which I'm going to cheat off of you. Thank you. 3,721.
If you cheat on a review, you're cheating yourself.
I'm not taking the quiz. I'm good. I actually took it already. Subtract the 121. Y squared equals 3,600. Then I have to square root both sides. And I get the square root of 3,600.
Are the numbers really this big on the quiz?
Yes, please.
Please no.
Probably not. I don't know if I'm not going to make any promises that it's that big, but you will have stuff you have to break down. I did say.
It's just makes
So what goes into 3,600?
600.
136. 100 becomes, you can do 10 and 10. You can do 6 and 6. Right there, you can cross out a pair of 10s and a pair of 6s. But if you don't catch it, keep going. This is a 2 and a 5. This is a 2 and a 5. A 2 and a 3. A 2 and a 3. So it's 2 times 5 times 2 times 5 times 2 times 3 times 2 times 3. Every pair brings 1 to the outside. So 2 2s, that's a 1 2 to the outside. 2 5s, that's a 5 to the outside. 2 2s, 2 3s. This is 10, 20, 60. So it's a big number, right? But it breaks down. Last one, what goes by itself? The y, right? The y is opposite the right angle. So this is 9 squared plus 19 squared equals y squared. What's 9 squared? 81. What's the square root of 19 squared? 19. Y squared equals 100. Y equals the square root of 100, which is? You can break it down if you don't know it. 100, 2 and 50. 2 and 25. 5 and 5. 2 2s. 2 5s.
Final answer is y equals 10.
Good. Y equals 10. So square root of 100 is 10. Okay, then we end with the way we started the day. This is the converse. If c squared equals a squared plus b squared, then what kind of triangle is it? Right triangle. If c squared is less than acute. If it's greater than obtuse. All right, so now the directions say classify the triangle as acute, obtuse, or right. The first thing you gotta do is identify what's the biggest side. That goes by itself. So if I look at A, 3, 8, and 10, what's the biggest one? 10. So I'm trying to figure out what's the relationship between 10 squared and 3 squared plus 8 squared. So 10 squared is 100. 3 squared is 8 squared. So 100 has what relationship to 73? Which makes this obtuse. Now B, what's biggest? Square root 11, square root 6, or 4? Remember, if it's not as easy to look at, we're going to square them each, right? So if I square the root of 11, I get what? 11. I square the square root of 6, and I get 6. I square 4, and I get 16. What's the biggest one? The 16. So 16 has what relationship to 6 plus 11? It's less than, which makes it
Lesser?
acute.
We love that English.
Grammar ends.
I said lesser.
It's okay. We're in geometry. I don't really care as long as you know it's acute.
Yeah, it's pretty cute.
All right, you do the last one. We're clear about this. I'm about to publish the quiz review on your home. You are doing that quiz review. That's your individual part. It is due Monday morning, but I'm going to post just the answers, not the worked out answers, but just the answers so that you can make sure that you're doing the right thing. If you are going to turn into me just the answers, realize you're going to get a 0. You need to show your work to get the credit. Please prepare for this quiz so that you can do well. Have a good weekend, guys.